2.1 functions. Most of this will be definitions, and so stick with me for a little while. We'll do some math work as well, but let's go ahead and get started. So x and y be two non-empty sets. A function from x into y is a relation that associates with each element of x exactly one element of y. Do the following pictures represent a function or a relation? So this is a bit of a mouthful here. So I'm going to try to explain that just through some examples. So if I'm looking at this first table that is given, then these would be your x's, right, usually, and these would be your y's. So that's what they mean with a function from x into y. We can also call this input and output. So let's check. So this x has one y, this x has one y, this x has two y's. So another way of writing this would be to say 1342 occurs not once but twice. So checking for a function or not has something to do with repeating x's, because in this case this x has as its y's 104 and 111, so the x value repeats, so this would not be a function. Okay, that makes it a relation. So I guess I should say here that's a relation. Okay, checking then the second table that is given to us, or actually it's called a mapping, to be honest with you, sorry. Dog 11, duck 10, rabbit 7, so every animal has exactly one life expectancy, so this would be a function. Okay, domain and range then are other words we can use to describe either input for your domain and output for the range. Or a lot of times the input is your x and the output is your y. So we'll check the second one here. This function has as its domain the values dog, duck, and rabbit. And the life expectancy values 11, 10, and 7 would be the range. Okay, this is a little more mathematical, so do the following: show a function or a relation. So I'm looking here, I see 2, -3, and 2 again. So do you see how the x value 2 is repeated? So if I was listing this in a table, so at 2 I would be 1, and at a -3 you would be 4, and then at 2 you could also be 5. So that's not a function, that is a relation. Whereas the next one that is given to us, I have a hard time not saying the word function here, hopefully you can recognize that as a linear function. So this clearly must be a function. The other way that you can check that is, well, plug in some x's. If you plug in an x of 0, you get a unique y. If you plug in an x of 2, 2 times 2 is 4 plus 1 is 5. So every x value has only one y value. Okay, and that's sort of the route that I'd like to go over here. But you know, this one's backwards. Now I'm not going to rewrite this. When I make my table here, I'm just going to plug in values for y. So zeros, for example, is a good one to use. So if I plugged in 0, I would get 3 times 0 squared minus 4, and 0 minus 4 is a -4. So that is the x value. So 1x, 1y. So that's great. But the squaring here means that both positive and negative values should give me the same. So if you plug in 1, so 3 times 1 squared minus 4, 1 squared is 1, and 3 minus 4 is a -1, you see that x of a -1 has a y of 1. But so does this one. If you use a -1, 3 times a -1 squared minus 4, and -1 squared is also 1. So again, this gives you a -1. So we're back to repeating x's. So this is a relation. You can do this algebraically. You would move the 4. Okay. So algebraically, you would want to write the y by itself. Then you would divide by 3. And then you have to remember that if you want to get rid of a square and you're doing the square rooting, you would end up with this: y equals plus or minus the square root of x plus 4 over 3. So you can see that every x you plug in here, well, not every x, but most x's that you plug in here will give you multiple y values. Okay? Okay, illustrating some language use with functions. So the name of the function is f. Okay, so the name of the function is f. Okay, the independent variable or the argument of f is p, so that would be the variable we're using. And if q is f of p, q is called a dependent variable. So fp, and let's just give you a function. So let's say that fp is equal to 2x plus 1. Then this blue line here would translate into saying, well, that means that I'm sorry, I gotta go back a second. We defined the function with the variable p, right? So this should be 2p plus 1. And then this line here is saying that 2p plus 1 is q. Okay, now that should look a lot like y equals 2x plus 1. So the input, the independent variable, or the domain values are your p's in this case, because we're not using x's and y's, and q is your output, or your range, or your dependent variable. If it's given that f of 3 equals 9, then 9 is the value of f at 3, or 9 is the image of 3. Graphically, that would lead us to do something like this, right? 3, sorry, no dot there, I just wanted a bigger tick mark. So we're at 3, and at 3, and I don't want to do the whole thing, we get a dot at 9. So f3 equals 9. Okay. Move into a little bit more algebraic stuff. So find the domain of a function defined by an equation. So domain deals with, so here's a non-official definition of domain. X values you are allowed to use. Okay, and then when I use that sort of a definition and I look at a, then I see a fraction, and I know in fractions that I can't divide by 0. So f of x is in great shape as long as x squared minus 2x minus 3 does not equal 0. I think this one's factorable, so x minus 3 times x plus 1 can't equal 0. So that means I get two values. I can't use x as 3 because I would create division by 0, and I cannot use x as a negative 1. So we would say the domain here is the set of all real numbers. That's what it says here. Start with the domain as the set of real numbers. If the equation has a denominator, exclude any numbers that give a 0 denominator. So I cannot use 3 or a negative 1. Okay, looking at b, I see x squared. And you can square any number, right? So the domain is all real numbers. Are there any values in the real numbers set that don't square? No, they all square. Now 0 is sort of unique because you get 0 squared is 0, but 1 and negative 1 both give you the same number, 2 and negative 2. But everything really squares, so we're good for that one. And then here we have a square root, okay? And that means that you need to make sure that the value underneath here needs to be a plus, right? Because the square root of a positive number works. If I use the square root of a negative number, then it won't work. So usually what we would do here is we would solve the inequality. 3 minus 2x has to be greater than or equal to 0. It's okay to be equal to 0 if you're in the square root, right? Because the square root of 0 is 0. So let's move this. On inequalities, I prefer to have the variable on the left, even when they're negative. I do have to remember that when I divide now by a negative 2, so I get 3 over 2 here, I need to switch this. So I need to have x's less than or equal to 3 over 2. Well, then that's the domain. So the domain is going to be x less than or equal to 3 over 2. It's sort of implied that it's a set of real numbers, so if you wanted to add that or not, it's really sort of up to you. Keep in mind that it does matter if this has a positive index. Now the index here is not visible, but a square root has an index of 2. If the index was odd, for example a 3 or a 13 or whatever else you want to do that is odd, this has as its domain all real numbers because, and I'm going to go back and use a cube root because I don't know many 13 roots. So, alright, that one. Because the third root of a negative 8 does exist, right? It's a negative 2. So it's okay to have negatives on the cube roots or any odd root, okay? So don't just automatically assume, hey, square root sign or radical sign, I have an exclusion in my domains. Okay, here is the domain in terms of an application. So a rectangular garden has a perimeter of 100 feet. Express the area of the garden as a function of the width and find the domain. Okay, so if the perimeter is 100 feet, okay, the perimeter being the distance around, then from here to here, from there to there, from here to here, which we'll call W again, and then from there to there, when you add it together, we should get 100, right? But that gives me two variables, right? I don't want to just say, well, 2 times the width plus 2 times the length is 100. What if, and so if you have trouble visualizing this, what if I said that the width was 20? If you said the width was 20, could we figure out what the length would be? Well, I think we can. I mean, if the width is 20, then this would be 20. And then let's see, so I had 100, and I just took away 40, so that leaves me 60. But I do have to divide it by 2, right? So 60 divided by 2 is 30. So then the length would be 30. Well, how can I use that? Well, what did I do? And I cheated a little bit. Maybe I should have written a little bit slower. But this 40 was 2 times 20. What value did I introduce? Because that is the variable. Because this 20 could have been 50, maybe. 50 is a little too big, right? Let's use a little smaller number, and we'll see that back in the domain. But the width could have been 5, could have been maybe 10, could have been 8.5, and a whole bunch of stuff. So what would have changed? Well, if the width is an unknown, so now I'm going to say the width is x, then the length would be 100 minus 2 times x, right? And then we divide that by 2. Now this one does divide out, so you actually get 50 minus x for your width. Okay? Well, then that allows me to write an area formula. So the area would be the width, x, times 50 minus x. And then now we can do something with the domain. We know that area has to be positive, right? Area is larger than 0. I guess it could be 0, but it's got to be larger than or greater than 0. Well, that means that 50 minus x cannot be less than or equal to 0. So if I look at 50 minus x, then that has to be greater than or equal to 0. Move this. And, move to negative 50. Make it a negative 50. Then divide, and it turns round again because of this. So we know then that the domain means that the width, since we defined x as our width, it has to be less than or equal to 50. It just means that if you make this 50, and if you make that 50, then that's 100 already. And if the perimeter is 100, then 100 minus 100 would be 0. There would be nothing left for your length. Okay? All right. Here is stuff that you can do. You can add functions, f plus g, the sum f plus g. You can subtract functions. You can also multiply and divide. I think we'll get to that. So what does that look like? Well, if two functions are given and you have to find f plus g, then you literally do 2x cubed plus 3 plus 4x cubed plus 1. And then usually we do want to simplify this. So f plus g of x is equal to 2x cubed plus 4, that is 6x cubed, and 1 plus 3 is 4. If you subtract f minus g, I got to do this in the right order, so it's, I just noticed that's a 2x squared, isn't it? I better go back and fix some things. Okay. If that's supposed to be a square, then we don't get a lot of stuff that adds. So f plus g of x is equal to 4x cubed plus 2x squared plus 4. Did I get them all? 2x squared and 3 plus 1 is 4. Yep. Okay. F minus g would be 2x squared plus 3 minus, and initially get in the habit of using parentheses. because this negative distributes to both of those. So you should get, we'll do it here. So in order, well, let's work this out one step further. So it's a negative 4x cubed minus 1. So in descending order, so the largest exponents first, and then 3 minus 1 is plus 2. Okay, f times g. So f times g would be multiplying, right? 2x squared plus 3, so this is a binomial expansion. Let's see. 2 times 4 is 8, so that's 8x5 plus 2x squared, so I did the first this way, and then 3 times 4 is 12, so 12x cubed, and plus 3 times 1 is 3. I'm going to be a little lazy. I'm just going to leave that, and we'll shove that up in here, if it will let me. Yep, it doesn't fit. So, alright. So that's f times g. And then f divided by g would be, it's actually the easiest one here. Because you literally can just write, well, that's 2x squared plus 3 divided by 4x cubed plus 1. Okay. Now, I didn't say anything about domain here at all, but you are supposed to look at the domain. It didn't say this here. I think in your textbook it will when you do the problem. So you have to keep the domain values in the back of your mind here. And the way that you do that on functions when you're either adding, subtracting, multiplying, or dividing is you have to look at the domain of the first, the second, and the last. So fortunately for us, these are both polynomial functions, and polynomial functions have a domain that is all real numbers. Now, polynomials just means that it's an x to some power that's positive, so a first, a second, a third, or a fourth. It could be just 0, because then it's actually a constant, because anything to the power of 0 is 1. So that's all real numbers. So does this one have a domain of all real numbers? So far you're good. Well, when you add, in this case, then you will not get any exclusions either. So there's nothing weird going on when you add stuff. Nothing weird goes on when you subtract stuff. Nothing weird happens when you multiply either. I mean, you just get, a larger expression, much more difficult to work with. But when you divide, you have to say, keep in mind that 4x cubed plus 1 cannot equal 0. And unfortunately for us, in this case, that is actually factorable, because that could be written as 2x cubed plus 1 cubed. Well, I guess it's fortunate because it allows us to actually find a value that you can't have. So the pattern of cubes would say that's 2x plus 1 times a squared, which would be 4x squared. Then I need to have a minus here. 2x times 1 is 2x. And then plus 1 squared is equal to 1. Now, the second part here, this one, this is always a quadratic that doesn't have any zeros. So this quadratic does not solve. It has two imaginary roots. So this will never be 0. So this part, this is never 0. Okay, hopefully you know that. If not, try to put that in your memory bank. It's nice to know because you don't have to worry about it. But 2x plus 1 can be 0, and it's not allowed to be 0. So that means that 2x can't be a negative 1. So x cannot equal a negative 1/2. So this new function here does have an issue with its domain. So you would have to say, well, the domain would be all real numbers except x can't equal a negative 1/2, because you end up with a division of 0. Okay. Summary. You may read this on your own. Some of this is vocab, and some of this might be a little bit new. The short of this is that it's a definition of a function which says that you can't have any repeating x's, so every x has a unique y. Functions, the ones that we most likely see, do have domains. It doesn't have to be specified for you. You ought to be able to figure out what the domain is by thinking about you can't divide by 0, you can't have negative even roots, and once we add logarithmics and exponentials and some other stuff, there's more to it. And then the other stuff is function notation. So y equals f of x, then f is just a symbol, it's the name of the function. Independent is x, y is the dependent. Keep in mind that we also call that input and domain, and we would call this output and range. And then the last one says something about image f of x is the value of the function of x. That means if you plug in x, f of x is what you get. And then that's it. Thank you.